going to look at the question 9. This is a continuation of the CA question for mathematics. Say determine dy dx at s is equals to 2, y is equals to minus 1. If this. Now, what kind of function is this? For what we learned, I taught you that this is implicit function. Can you still remember? We said this is implicit function. So let us differentiate this. When you differentiate, you are going to consider this like product rule. First, differentiate x. When you differentiate x, it's going to give us 1, right? Multiplied by y squared, going to be 1 multiplied by y squared, plus differentiate y squared is going to give us 2y, but then you are going to add dy dx, right? Then multiply by what? This x here. You have differentiated this. I have taught you how to go about implicit function before now. Abina. So when you differentiate this 3x squared, it's going to give us what? 6x. Everything. When you differentiate 10, it's going to give us 0. So let's rearrange. This will give us 1 times y squared will give us y squared plus what? 2xy dy dx plus 6x is equals to 0. Now, take this 6x to this other side. So this will give us 2xy dy dx is minus 6x minus y squared. Are you getting it? This one will come to this side. So divide both sides by 2x y, 2x y. This cancel this. Our dy dx so dy dx is equals to this whole thing you have here, which is minus 6x minus y squared divided by 2xy. But they told you x is 2, y is minus 1. So what are we going to do? Wherever we see x, put 2. Wherever you see y, put minus 1. So that our dy dx will be minus 6 bracket 2 minus bracket minus 1 square, all divided by 2 bracket minus 1. Okay, 2 brackets, 2 first, bracket minus 1. So your dy dx would be 6 times 2 is 12. So this would be minus 12. Minus 1 square will give us 1. Minus 12 minus 1. This multiplied by this will give us minus 4. Are you getting it? So that at the end of the day, what are we going to have? This will be minus 12 minus 1 will give us minus 13 divided by minus 4. So the correct answer to this question will be 13 over 4. Is that okay? It's a very simple question. A very simple one. Let's see the next one. Still the same question. Now the next question says find the first derivative or determine the first derivative of the function. Now you are going to use the product rule here. Product rule says u prime multiplied by v plus v prime multiplied by u is equals to dy dx. So in this question, we have to y is equals to e 2s natural logarithm of 4 x raised to the power of 4. Now we can say let this one be u and let this be v. So our u is e to the power of 2x and our v is the natural logarithm of s to the power of 4. Take this 4 to the back from logarithm, which will give us 4 natural logarithm of x. So we have to differentiate u. So du, that will give us our u prime. So u prime, when you differentiate e raised to the power of 2s, I first of all say you differentiate 2s, which will give us 2, and then multiply by everything again. Then our v prime will be 4. When you differentiate natural logarithm of x, it's going to give us 1 over x. So our v prime, 4 over x. Is that okay? So that at the end of the day, what are you now going to have? Our dy dx would be equals to u prime is 2e 2x multiplied by v is 4 natural logarithm of x plus v prime is 4 over s. U is what? E to the power of 2x. So that dy dx will be equals to this multiplied by this will give us 8e2s natural logarithm of 4 plus 4 over x e to x. And that will be the answer to that question. It's a very, very simple one. All right. All right. So that is the answer to that question. Let us see the next question. This is the next one here. Given that s is equals to sine 5 theta and y is equals to cos 15 theta, what is the expression for the y ds? This is what we call composite function. No, it's not composite function. What is the name of this function? Is it composite? There's a name we call it then. Not composite. I know one of those functions. Oh, what am I forgetting? But then we have to solve. Now, for this particular one, our dy dx is usually our y prime divided by x prime. Is that okay? What does that mean? It's more like is dy d theta divided by dx d theta. So first of all, we need to find the x d theta. X, this is hyperbolic function sine 5 theta. Your dx over the theta will be, when you differentiate this will give us 5 cos 5 theta. All right, based on what we have learned. So that you differentiate the 5 theta, use to differentiate, multiply. When you differentiate sine theta, it will give us cos theta, then multiply everything again. These are things I've done before. So your dy, your y is cos 15 theta. Dy d theta will be 15 sine 15 theta. All right, so that our dy dx, what do you say our dy dx is? Dy d theta divided by the s d theta. Dy d theta is 15 sine 15 theta divided by 5 cos 5 theta. This cancel this. The y dx will be 3 sine 15 theta divided by cos 5 theta. And that is the answer to that question. All right. Let us see the next one. All right, so we are going to look at the next question in the series of questions for the Maths 104 lecture series. All right, so the next question says, determine the value of x at which the minimum point of the function is equals to 0. Now, how do you determine the minimum point? The minimum point is the point where the y, the x are equals to 0. All right, I have actually taught you how to go about questions like this before. So first of all, we are going to find the y, the x. So we can say the y, the x is equals to, when you differentiate this, it's going to give us 3s squared plus, when you differentiate 2s squared, it's going to give us 4x. When you differentiate 10, it's going to give us 0. So the y, the x is 3s squared plus 4x. Now this must be equal to 0 for us to calculate the minimum point. So 3s squared plus 4x is equals to 0. This will actually give us the stationary point, which can be a minimum point or a maximum point, as the case may be. All right, so let us look for x. X can be two values since the highest power here is 2. So what is common between this and this, of course, is x. So you have x bracket 3x plus 4. If you take x out, here will be left with 3x plus 4 equals to 0. So we can say x is equals to 0 and 3x plus 4 is also equals to 0. So x is equals to 0 and 3x is equals to minus 4. So divide both sides by 3. Your x is minus 4 over 3. So x can be 0 and x can be minus 4 over 3. Now, how do we now determine which of them is a minimum point and which of them is a maximum point? Now, for us to determine the minimum point and the maximum point, you are going to use the following. Okay, you are going to do the following. Let me solve it here. Your y prime, you are going to look for y prime. That means the second derivative. Second derivative, this is what you have at first derivative, 3s squared plus 4. Second derivative will be what? When you differentiate this one again, our dy dx initially was what? 3s squared plus 4x. Abi? That's our dy dx, exactly. So differentiate this one again, will give us a second derivative, which of course will give us 6s plus 4. Now, you are now going to substitute each of these values into the second derivative. So we now say at x is equals to 0. What value will that give to us? 6 bracket 0. Wherever you see x here, put 0 plus 4, which will be 0 plus 4, which will be equals to 4. Now, once the value you have is greater than 0, that is the minimum point. 4 is greater than 0. So this point at s is equals to 0 is a minimum point. Now, can we still try it for the other point you have there? Y prime prime is 6s plus 4. The other point you have is when x is minus 4 over 3. So y prime prime will be 6 bracket minus 4 over 3 plus 4. y prime prime will be equals to this multiplied by this will give us 2 times this will give us minus 8 plus 4. Y prime prime will be equals to minus 4. And that will be the answer to that question. All right? Exactly. So, and this minus 4 is less than 0. So minus 4 is less than 0. Now, the point where the value is greater than 0 is the minimum point. So the minimum point is at x is equals to 0. You can write it. Minimum point is when s is equals to 0 and not when s is equals to 4 over 3. So that's the answer to that question. Let us see the next one quickly. The next one says locate the point of inflection on the function. This is the function that was given to you. How do we calculate the point of inflection? Now, the point of inflection occurs when the second derivative changes sign. All right? That point where the second derivative changes sign is the point of inflection. So we have gx. They gave you the function gx, which is 2s to the power of 3 minus 6s squared plus 1. When you differentiate this, it's going to give us 6s squared minus, when you differentiate this, it's going to give us 12s. This is our g prime, first derivative. So g prime prime of x would be, when you differentiate this, it's going to give us 12x minus 12. Now we said the point of inflection is that point, whereby this should give us 0. So at point of inflection, you can write it. At point of inflection, my dear student, our g prime prime of x should give us 0. So here will give us 12x minus 12 is equals to 0. And then 12s is equals to 12. Divide both sides by 12. X would be equals to 1. So that is the point of inflection. Now, that is for the x-axis. We should look for the y-axis. So to look for the y-axis, substitute this x into this equation here. This other equation here. The first equation, which is the original equation. So substitute 1. This is 1 into that. And this will give us 2 bracket 1 raised to the power of 3 minus 6 bracket 1 square plus 1 to get the y-axis, because gs is still the same as y. So y will be 1 raised to the power of 3 is 2 minus 6 plus 1. And this will give us what? Minus 3. So the points of inflections are 1 and minus 3. These 2 points here are the points of inflection. All right? So let's see the next question. The next question says, find the stationary point of the function. Now, when we talk about the stationary point of the function, we are talking about the point at which the y dx is equal to 0. Are you getting it now? The x and y point at which the y dx is equal to 0. So let us find that. Solution, y is what? 2 over 3 x to the power of 3 minus what? 2x squared plus 1. And then y prime is equals to, when you differentiate this, it's going to give us 2x squared, right? Exactly, because this 3, we cancel this 3 on that. So we have 2s, then minus 1 from the power, which is 2s squared, minus 4x plus 0. So our y prime is what? 2x squared minus 4x. Are you getting it now? Exactly. Now at this point in time, we said stationary point is the point at which our y prime is equals to 0. So it means 2s squared minus 4s should be equals to 0. Now, what is common between these two things here? Of course,